All right, good morning, geometry. So today we're going to begin on the week 11 notes. Week 11 notes, it's 5 pages long, and we are going to be starting it off with something we've already kind of done, which is dilations. So we've already touched on dilations, but as I said, this unit we will be getting into dilations a little bit more. So let's look at them. Let's see. So we got dilations. We've already seen them. A dilation is a transformation where the image of a figure is similar to the original, also known as the pre-image. And we talked about image is like after it's transformed, the pre-image is before it's transformed. And we also talked about how dilations are the transformation where it's going to change its size but not its shape. And that's pretty much the definition of similarity, that it's going to be the same shape but a different size. So with dilations, there's always going to be a scale factor. And when we did that, I think there was a delta math activity you guys did where you had to determine like the scale factor of a dilation. And the scale factor, it's represented as K. I don't know why it's K, but if you ever see K in a problem, especially with dilations, it probably means scale factor. And K is the distance from the center to P prime divided by the distance from the center to P. And typically, the center of dilation is going to be the origin, especially on a coordinate plane. Or you can just think of it as prime over the original. And it's always going to be prime over the original. So if we have this example here, I have my center here at C, and then I have my two figures. I have this P prime, so there's the prime one, and then there's the original. So from the original to get to the prime, it shrunk. So in terms of dilations, we would call that a reduction. This is a reduction. If it shrinks, it's called a reduction. All right, so we want to calculate our scale factor. We want to calculate K. So it's going to be the distance from the center to the prime. So it tells me, well, that distance is 4. So let's say K equals prime over original, just to rewrite it. And that's going to equal, so we said the distance to the prime was 4. The distance to the original, or to the pre-image, is not 3. I know there's a 3 right there. That's the distance from the image to the pre-image. We want the distance from the center to the pre-image. So distance from the center to the pre-image is this entire length. So it's the 4 plus the 3, which is going to be 7. And I cannot reduce that fraction. 4 over 7 is irreducible. Therefore, that's my solution. 4/7 is the scale factor of the image to the pre-image. So with a reduction, our scale factor, our K value, is always going to be less than 1 with a reduction. So if it's getting smaller when it goes from the image to the pre-image, or from the pre-image to the image, it's going to be less than 1. And 4/7, I don't know what that is as a decimal. It's a repeating decimal, but I do know that that is going to be less than 1. All right, I'll continue on. So our next problem, it doesn't give us a P or a P prime, but it does tell me which one's the pre-image and which one's the image. And the pre-image is the P. The image is the P prime. It's always going to be that way. Pre-image is P, image is P prime. So to get from the pre-image to the image is getting larger. So this is an enlargement. And we're going to do the exact same thing here. So I know that K is going to equal the prime over the original. So the distance to get from the center, C, to the prime, once again, it is not this 4, it's this 8 plus this 4. So I have this 8 plus this 4, which is going to give me 12. And then the distance to the original, well, that's just the distance to P, which is just 8. That one is already labeled for us. So our scale factor here is 12 over 8. And if I can reduce a fraction, I'm going to. So 12 over 8, I can divide both those numbers by 4. So 12 divided by 4 is 3. 8 divided by 4 is 2. Our scale factor here was 3 over 2. And for an enlargement, K will always be greater than 1. Okay. So continuing on, we have some example problems here where we have to find the scale factor. So let's see. It doesn't tell me which one's my P and which one's my P prime. However, the vertices of this smaller triangle are labeled A, B, and C, or the vertices of this larger triangle are A prime, B prime, and C prime, which tells me the smaller one is my P and the larger one is my P prime, because the primes go with the primes. So once again, my scale factor, K, it's going to be the prime, the distance of the prime divided by the distance of the original. So the distance of the prime, it's going to be the entire side length there. That should not be a curve, but whatever. Okay, yeah. It should be the entire side length, which is the 3 plus the 2, which is 5. And the distance to the original is given to us in the problem. It's just 3. 5 over 3 is irreducible. Therefore, K is just 5/3 in this problem. And since 5/3 is greater than 1, we know this was an enlargement. And we could have also told it was an enlargement because it's going from P to P prime and it's getting bigger, obviously, if we just look at the picture. All right, next problem, same thing. We want to find the scale factor. So my bigger triangle is labeled ABC, which tells me it's going to be my P. And then A prime, B prime, C prime is my P prime. So I'm going from P to P prime. And this one doesn't have distances labeled. It doesn't have the distance from the center to a certain point. However, because this is just a dilation, I know that these are similar figures because we know that similar figures, the only thing that really occurred between two similar figures is a dilation. So I know they have corresponding parts. I could pick any of these corresponding parts really, but I'll go with this 16 and this 4 because I know they're both facing that C. I could have also gone with 12 and 3 or 8 and 2. Either way, it would work. And it's still fine. I'm still going to do the exact same thing. I'm going to do prime over original. It doesn't always have to be the distance as long as it's corresponding things. So prime over original, which that prime was BC, so, and my bad. The prime was B prime C prime, right there, because that was 4. And the original was BC, so B prime C prime over BC. And that would give me my scale factor, which is 4 over 16, which reduces to 1 over 4. So this one had a scale factor of 1 over 4. And as I said earlier, it went from the big one to the little one. Therefore, it was a reduction, and 1/4 is less than 1. Therefore, we know that is a reduction, yeah. All right, let's continue on. So, for this next example, we want to find the scale factor and solve for x. So I'm doing 2 things here, finding the scale factor and solving for x. So to find the scale factor, I know that I can just do the same thing I've been doing because I have the distance to p prime and the distance to p. So this distance to p prime is this 6 plus this 12, which is 18, and the distance to p is just the 12. So my scale factor, which is k, is going to be 18 over 12 because of the distance to the prime divided by the distance to the original. And that reduces 18 is divisible by 6, and 18 divided by 6 is 3. 12 divided by 6 is 2. So our scale factor here is 3 over 2. But now I want to solve for x. So I'm going to do it in pretty much the same way. However, I'm going to set it up as a proportion because I know scale factors are going to be proportional on both sides. So I already said that it was 3 over 2 was my k. So 3 over 2 is going to equal the distance to the prime. So if I'm looking at this, the distance to the prime here is that entire length. And that entire length, well, it's the 5 plus the x, so x plus 5. So the distance to the prime is x plus 5. And the distance to the original is just the x. So we know how to solve this problem. We've been doing it. I'm going to use my butterfly method. So I have 3 times x is 3x. And then I have 2 times x plus 5. I'll distribute that 2. So that gives me 3x still on this side. 2 times x is 2x. 2 times 5 is 10. I'll subtract 2x from both sides. And that's going to give me x equals 10. So I did both things it asked me to do. I found my k and I found my x. And that's how we would solve a problem like that. And we will do the exact same thing on this next problem. So let's see, find the scale factor first. So my scale factor is the prime over the original. The distance to the prime is 4. I don't need to label that one. It's already labeled for me. So the distance to the prime is 4. The distance to the original, though, is that 8 plus the 4, which is 12. So distance to the prime divided by distance to the original. And I know that this one is using Q instead of P, but it really doesn't matter what letter they use. It'll most likely be a capital letter. And P is the most common one, but sometimes we'll see different letters as well. So I say K equals 4 over 12. And 4 over 12, I can divide both those by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So I have a scale factor of 1/3 here. So I'm going to set up my proportion now to solve for x, or solve for y. So I have 1/3 equals, so let's see, I want the distance to the prime, so the distance to the prime is y. The distance to the original is y plus 3 plus y. So if I combine like terms in that statement, so I'll actually write that out. So y plus 3 plus y. Those are going to combine to become 2y plus 3. So my distance to the original was 2y plus 3. And now I'm just going to solve this proportion. So I have 1 times 2y plus 3. Well, 1 times 2y plus 3 is just 2y plus 3. I don't even have to, I mean, I could technically do this, but anything times 1 is just itself, so I don't need to do that. And then I have 3 times y is 3y. So I have 2y plus 3 equals 3y. I'll subtract 2y from both sides. And that just gives me 3 equals y. So I solved for the scale factor, which was 1/3, and I solved for y, which was 3. And there we go. So that was how we would do a problem such as that. Are there any problems like that today? It looks like there are a couple on today's assignment that are going to be similar to that. I hadn't really looked at today's assignment very much. Sorry, I'm looking at it right now. Okay, continuing on. So, number 5, without graphing, determine the coordinates of a figure, typo there, with vertices A, -3, 2, B, 1, 3, and C, 2, -1, that is dilated by a scale factor of k equals 3. Okay, we've already done this. This is something that we already know how to do. So I'm going to write out, I have A prime is going to be, to dilate this by a scale factor of 3, all I have to do is multiply everything by 3. So I have this -3 times 3, this 2 times 3, this 1 times 3, this 3 times 3. So to get from A to A prime, I have -3 times 3 is -9. I have, sorry, that looks more like a plus sign and it's annoying me a bit. There we go. Okay, so yeah, times 3. 2 times 3 is 6, so A prime is at -9, 6. B prime is at, well, 1 times 3 is 3, 3 times 3 is 9. And C prime, I have 2 times 3 is 6, -1 times 3 is -3. So I just took this point and multiplied it by 3 as well. So that's my answer. I determined the coordinates of the figure after the dilation. There we go. That's all I needed to do. And for number 6, it's kind of going to be the same thing. It's something we've already done before, and I know people struggled with it, so hopefully today's notes clear things up a bit. So we want to determine the coordinates of the figure below after it's dilated by a scale factor of k equals 1/2. So I'm going to start by determining these coordinates. So I have A is at -4, 5. And after the dilation, I'm going to have A prime, and I'm doing this by a scale factor of 1/2. So 1/2 times -4, or just -4 divided by 2, because that's the same thing as multiplying by 1/2. So -4 divided by 2 is -2, and 5 divided by 2, I could say 5/2, or I would actually put this as a decimal because it's easier to graph a decimal than a fraction. So I'll say -2, 2.5. So that would be my coordinates of A prime. Now I want to determine B prime. So my original B looks like it is at 6, 3. So 6, 3. And I just want to divide both those numbers by 2. 6 divided by 2 is 3. 3 divided by 2 is 1.5. And to determine C, let's see, C is at the point 0, -6. Just want to do 1/2 times both those numbers. So C prime, 0 times 1/2 is 0, because anything times 1/2, or anything times 0 is 0. And -6 times 1/2 is -3. So this A prime, B prime, C prime is going to be my new triangle. And the problem also said graph A prime, B prime, C prime. So I need to plot those points. So let's see. -2, 2.5 is right about there. I'll even label it A prime. B prime was at 3, 1.5, which is right about there. Wait. I put my A prime in the wrong spot. My bad. A prime should have been there. This is B prime. And then I have C prime, which will be at 0, -3, which is right there. And now all I would like to do is connect these points to make my figure. So there we go. That is the coordinates of the figure after it's dilated by that factor of 1/2. And that would be our complete answer there. And I know we've done something like that before. So hopefully 5 and 6 were a little bit of a refresher, as well as like clarifying some things that I know we were struggling with. Because I know when I had those one-on-one meetings with everybody, a lot of people said they didn't understand dilations, which is perfectly fine because we're doing dilations now. All right, let's look at today's assignment. This is what today's assignment is going to look like. Questions 1, 2, and 3, you're just circling the things inside the parentheses. So you would either like, it tells you a statement. It says ABC is mapped onto A prime, B prime, C prime by a dilation. You would circle either congruent or similar. You would circle either larger or smaller. You would circle either reduction or enlargement, et cetera, et cetera. For this part here, 4, 5, and 6, For A, you want to say if it's a reduction or an enlargement. That's what it's asking for when it says identify the dilation. Reduction or enlargement. And then B, find the scale factor. You can do that. Let's see. For 7, 8, and 9, it wants you to determine the scale factor by using those proportional sides, and then solve for all the variables. So for number 7, I want to see solutions for x and y. For number 8, I want to see solutions for x, y, and z. Yeah, number 9 also needs x, y, and z. 10 and 11, it gives you the scale factor, and you don't even need to plot it, you just need to determine the new coordinates. So this one should be pretty simple. You just determine the original coordinates, multiply them by the scale factor. And then 13 and 14, or no, wait, 12 and 13. Oh yeah, 12 and 13. So you want to find the coordinates of the prime and then plot it. So on 10 and 11, you didn't need to plot it. On 12 and 13, you do, but it's basically the exact same thing. It's just telling you a scale factor. You just need to plot the new points. And then for 14 and 15, you're just finding the scale factor that was used. And that is going to be today's assignment and today's notes. So that's all I have for you guys today. I will see you tomorrow.